Okay, gang, they're going to get even trickier. Okay, we're going to approach this problem in the same way. So we're going to find the coordinates of where the line and the curve cross. Now, passes through 1, 6 and the minimum is at B. So in fact, I know that this coordinate here, A, must be 1, 6. So I'm going to drop my parachute there, that's 1. And what I want to do is find the coordinates of B. All right, so I can drop my parachute there. Now, all I do know about B is that the minimum is at B. So what do we know about a minimum point? Aha! We know that at a minimum point, the gradient is 0. So how clever is this question? We're going to have to do some differentiation before we do the integration to find the area of the curve. It's a beautiful calculus question. Calculus means differentiation integration. Okay, so dy by dx is 0. So let's actually differentiate this function. So we're going to get dy by dx equals the 3 over 2 will come down with the 2. They'll times together to give me 3x. Let's reduce the power by 1, gives me a half, minus 6. Okay, so I know that 0 equals 3x to the half minus 6. I'm going to move my 6 over, gives me 3x to the half. Divide by 3 gives me 2. So 2x to the half. X to the half is the square root, so let's not get this wrong. And how do we get rid of a square root? We square, which gives us 4. So in fact, that parachute coming down from B is 4. Right, let's move that over. Oh, my parachutes have moved over as well, so let's put them back in. So this parachute here is 1 and this one here is 4. So now what we're going to do is we're going to do our usual to find the area of that shaded bit. Now, do you remember we said drop the parachute and then Stella said integrate something? So the area of a curve is found by the integral of y with respect to x. So I am going to integrate 2x to the 3 over 2 minus 6x plus 10 with respect to x, and I'm going to integrate it usually between the limits that I've just found. I say usually because it's not always. So if we integrate between 4 and 1, we're going to get this area here between the two x limits, the x-axis and under the curve. So we're actually going to find that area there. Okay, so let's start putting in our arrows. This will be x to the naught with an arrow in here. So we're going to get 2 bracket bracket x minus 6 bracket bracket x plus 10 bracket bracket x. And if we add 1 to this power, 3 over 2, if we add 1 we're going to get 5 over 2 and then flip it. If there's a power of 1, if we add 1 to that power we're going to get 2 and flip it. And if we add 1 to that power we're going to get 1 and flip it. Okay, so that's what it looks like into a bracket with a 4 and a 1 coming out. Okay, let's neaten that up. We're going to get, 2 over 1, 2 times 2 is 4, and 1 times 5 is 5. So we're going to get 4/5 x to the 5 over 2, 6 over 1. 6 times 1 is 1, 1 times 2 is 2. So we're going to get 3 minus 3x squared plus 10x to the 1, and that is going between 4 and 1. Okay, let's feed our numbers in. So 4/5 times 4 to the 5 over 2 minus 3 lots of 4 squared plus 10 lots of 4, that's the first bracket, minus 4/5 times 1 to the power of 5 over 2 minus 3 times 1 squared plus 10 lots of 1. That's a 1 there with a big massive bracket. Okay, 4 to the power of 5 over 2, I'm going to do that on my calculator. And then times that by 4/5, that gives me 108 over 5. 4 squared times 3 gives me minus 48, plus 4 times 10 is 40, so that's the first bracket. And then the second bracket is really rather nice, so it's 4/5 minus 3 plus 10. Okay, neatening that up, I get in the first bracket 88 over 5 minus 39 over 5 from the second bracket, and altogether that comes to 49 over 5. So that red area, the red area there, is 49 over 5. Okay, now that is not the area I want. Will this disappear? Why does it always do that? It takes my little area with it. Let's put the area back in. So that is not the area I want. There's my 1 and my 4. This is the red area here. Right, that bit there is 49 over 5. Let's write that there, 49 over 5. So what I'm actually needing is this area here. Now if I show you in green, there's actually from the top there, down the bottom, down. You notice what shape that's making? It's a nice trapezium, isn't it? So if we drew it out like so, what do we know about the area of a trapezium? Okay, the area of a trapezium is a half a plus b times h. So a plus b are the two sides here. So that's a and that's b. They're the two parallel sides. Now we know that this one is already 6 because we knew that it passed through 1, 6. That coordinate there is a 1, 6. So we know it's 6 high. All right, so that definitely from there to there is 6 high. But we don't know the height of this one here, this height. But we can find it fairly easily because when x is 4, we've got an expression here that tells us our y. So let's see if we can find that height first. So y is 2 lots of 4 to the power of 3 over 2 minus 6 lots of 4 plus 10. Okay, y equals 2 lots of 4 to the power of 3 over 2 is the same as 4 to the half cubed minus 24 plus 10, and therefore y equals 2 lots of 4 to the half is 2, 2 cubed is 8, so 2 lots of 8 minus 24 plus 10, so I reckon it's 16 minus 24 plus 10, y equals 16 minus 24 is minus 8 plus 10 is 2. So I reckon that little height there is 2. So that looks like that. And then the h, so we've got a plus b, so we've got 6 plus 2, those are the parallel sides, times h. And h is always it's strange it's an h, it's always the width, but they call it the height. So the width between 1 and 4 is 3. So a half of 6 plus 2 is 8, times 3, 8, 16, 24, I reckon it's coming out as 12. Okay, so overall, the overall area, the final area of my little shaded region. So the area of the shaded will be the area of the trapezium, which is 12, minus the area of, I've exaggerated that to make it look like an actual curve, my red bit, which we said was 49 over 5, and 12 minus 49 over 5 on my calculator is 11/5. Done. Okay, the only thing I know about this question is I've got to find the shaded area, and I know the curve, and that's it. So I think a good starting point would be to see if we could find the coordinates of A and B. And then see what happens from there. So the coordinates of A and B, can you see they're both turning points? What do we know about a turning point or a stationary point? We know the gradient is 0. So again, here comes this funny idea of doing some differentiation before we integrate. So we're actually going to find dy by dx equal to 0. Okay, let's start off with that. So dy by dx will be 3x squared minus 16x plus 20. And we're wanting the turning points because A and B look like turning points to me. A looks like that, doesn't it? And B looks like that. And we're going to put that equal to 0 and solve it. Okay, it looks to me like it will factorise okay. That's it. Let's factorise that. And therefore x is coming out as 10 over 3 or it's coming out as 2. Okay, so 10 over 3 is bigger than 2, isn't it? So I reckon let's put the parachute in. This one here must be coming out as 2, and this one here is coming out as 10 over 3. Okay, so do you remember we said the next trick was to decide that we were going to integrate something? I'm just going to move that away. Oh, it always takes that with it. Let's put that back in. So this one is coming out as 2, and this one is coming out as 10 over 3. So do you remember we said then the next stage is to integrate something? Okay, so the area is found by integrating the curve with respect to x. So we're going to integrate x cubed minus 8x squared plus 20x with respect to x. Now, most of the time, we integrate between the limits we've just found. So we would integrate between 10 over 3 and 2. But look, if we did that, that would give us this area. Now, that's actually not really very helpful. So this is a classic scenario where we integrate between different limits. So watch why I'm going to integrate. I'm going to integrate between 2 and 0. Because if I integrate between 2 and 0, can you see that will give me the area underneath the curve, the x-axis between 2 and 0. It will actually give me sort of almost like half of the little bit of the area that I want. Okay, that's clever, isn't it? I want you to be really careful with that. 99% of the time you'll integrate between the limits that you've just found, but occasionally you won't. Okay, so let's start off with our integration. So we're going to put a number. I'm going to call 20x to the 0, all right, and put my little brackets in. So it's going in 1 bracket x minus 8 bracket x plus 20 bracket x. And I'm going to go between 2 and 0. So I'm going to add 1 to the power is 4 and flip it. I'm going to add 1 to the power is 3 and flip it. I'm going to add 1 to the power is 1 and flip it. And I'm going to get a quarter x to the 4 minus 8 over 3 x cubed plus 20 x to the 1, and that's going in between 2 and 0. Okay, so let's feed the 2's in. So we're going to get a quarter 2 to the 4 minus 8 over 3 2 cubed plus 20 lots of 2. That's the first bracket. Oh, thank God the second bracket's a 0. A quarter 0 to the 4. Still write it in though, even if it's a 0, because it's your method. 0 cubed plus 20 lots of 0. Okay, 2 to the 4 is 16 divided by 4 is 4. 2 cubed is 8. 8 eighths are 64 minus 64 over 3 plus 40. And phew, the last bracket comes to 0. Okay, so 44 minus 64 over 3 is 68 over 3. Okay, so that is that little area there. Let's move him. So I reckon that little green, are you happy guys? Here's the green area. Yep, here's the green area. So I'm just going to move him up. Notice my little green area moves as well. So the green area there is 60, what do we say? 68 over 3. Right, now, watch this. This is clever. The little area that I'm left with is there. So I reckon that that red area is a triangle. Phew. Area of a triangle is easy. So I've got to go between 2 and 10 over 3. So the difference of that is 4/3. And the height, now I've got to do the height. What's the height of this triangle here? Okay, that's okay. That's a y value. And I know the x value. The x value is 2. So let's just pop that into here. So y equals 2 cubed minus 8 lots of 2 squared plus 20 lots of 2. So I reckon it's coming out as 8 minus 4 eighths, 8 centimetres, 32 plus 40. I reckon the y value is coming out as 16. Okay, so that's okay. Area of a triangle is a half base times height. So it's a half times 16, well, that's the height, times the base, which is 4/3. I reckon that it's coming out altogether as 32 over 3. Okay, final answer. The final answer, the overall final area is the area of my little green bit. There's my little green bit, which was 68 over 3, plus the area of my red triangle. My red triangle was, what did we say that was? 32 over 3. And if we add those together, the final area is beautifully coming out as 100 over 3.